Today's video is brought to you by section 18F, Exponential Equations. So, I got my coffee. What we're going to be looking at today is we have an exponential, a to the power x, and it's equal to another exponential, which has the same base. When this happens, a to the power x equals a to the power k, then it has to be that if I have the same bases, the exponents have to be equal. So, to give you an example, or well, I actually got 4 examples here. First one, if I have 2 to the power x equals 32, I have to change them somehow so that they have the same base. I happen to know that 2 power x is equal to 32 is the same as 2 to the power 5. So 2 multiplied by itself 5 times is going to be 32. This being said, 2 to the power x, 2 to the power 5, based on this, x equals 5. And how do you know it's pre-IB? The examples get more difficult. So we get that one down. That hopefully was pretty straightforward. And this one, 3x minus 2 equals 1 over 9. Have to change them to the same base. Well, first thing, 1 over 9 is equal to 9 to the negative 1. 9 is equal to 3 squared. But it's, so that means I have 3 squared to the negative 1, which is going to be 3 to the negative 2. Drop my eraser here. So what does that mean? That means I then have 3x minus 2 equals 3 to the negative 2. Same base. So this is going to equal this. So x minus 2 equals negative 2. Add 2 to both sides. X equals 0. Those aren't too bad, I hope. Those are our first 2 examples that we're looking at. Like I said, they get a little bit more difficult, and you really need to know your laws of exponents. That's why I sent the review stuff on that. That's finished, that's finished. Alright. So what do I get next? We have 6 times 3 to the power x equals 54. Well, 3 to the power x, and I got a 6 and all this other stuff. It looks crazy. What am I going to do? Divide both sides by 6. Get rid of this. Remember, I want it to look like this, a to the power x. So in this case, I want it to be 3 to the power x, and just 3 to the power x. So I divide both sides by 6, and now I have 3 to the power x equals 9. Well, 9 equals 3 squared. Same base, exponents must be equal, x equals 2. Flying through these. Hopefully they're making sense. And of course, the last one's going to be the tougher one. So I have 4 to the power x minus 1 is equal to 1/2 1 minus 3x. So I got to think about it for a second. Okay, how can I make this work? This is a 4. This is a 1/2. I know that 4 is equal to 2 squared. And I know that 1/2 is equal to 2 to the negative 1. So I can make this work. So by doing that, I have 2 squared, which used to be 4. And that's all to the power x minus 1. And that's going to be equal to 2 to the negative 1 to the power 1 minus 3x. Distributive property, power of a power, so it's now going to be 2 to the power 2x minus 2, and that's going to be equal to, so negative 1 times this, that just switches them around, so I have 3x minus 1. Same bases, so I can drop the bases, so I get 2x get into the algebra, we'll add 2 to both, you know what, we're going to subtract 1 from both sides. So I have 2x minus 3 equals 3x. We're going to subtract 2x from both sides. Negative 3 equals x. Well, there, we're done. X equals negative 3. So that's using equations, exponentials and equations to do exponential equations. Next step, next section will be the worst one. It's the introduction to logs. And those, there are going to be situations where we can't make the exponents equal and do a nice simple operation like this, and they make our life a little bit easier.